This video goes over today's warm-up. The first question asks you to plot this data on the dot plot below. The data is already organized from the smallest number to the largest number, so I'm just going to have to figure out a scale for my dot plot that makes sense. It looks like I go from 3 to 13, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, that works. So I'm just going to go 3, 4, 5, 6. Okay, and then for a dot plot, you essentially just put a dot above the number to represent that data point. So for example, I have one staff member whose foot size is a 3.5, so I'm going to put a dot halfway between 3 and 4. I have one person with a shoe size of 4, so one dot there. When I get to 7, I have 3 7s, so I'm going to put 3 dots above 7. 1 over 7.5, 1, 2, 3, 4. I have 4 8s. I'm going to start labeling this. So I have 3 7s, I have 4 8s. One 8.5, 1 10, 1 10.5, an 11, a 12, and a 13. So you might have chosen a different scale. Whichever scale you chose, your dot plot should look something like this shape. Okay, so the question is this data more symmetric, skewed left, or skewed right? How do you know? This is a little bit tricky because it doesn't look perfectly either way. It doesn't look particularly skewed right, doesn't look particularly skewed left, and it doesn't look particularly symmetric. In general, I would say it's more symmetric because the peak, like the mode, happens at the center of the data set. So it's kind of like there's this gathering of staff members who have like an average shoe size 7 to 9, and then we have like some people over here who have really small feet, and then some people over here who have really big feet. So, but most people kind of fall in the center, and it's relatively symmetrical. This shape, as we're going to learn, is actually called a bell curve, but I would say that it's relatively symmetric. And I'd say most data falls towards the middle, which is how I can tell it's symmetric. Okay, the mean of the data set is going to come knowing the definition of the mean. Mean is the average, or we add up all the numbers, and divide by amount of numbers. So in this case, I'm going to add up this string of numbers, and I'm going to divide by the total number of numbers in the data set, which let's just count. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 numbers in the data set. So I'm going to add them all together in my calculator. And I get 180.5. I'm going to divide 180.5 by the total numbers in the data set 16 to get my average of 11.2. Which doesn't really make sense. Re-add, I might have done something wrong. Okay, so now I'm getting 133. I must have added wrong the first time. So I'm going to go 133 divided by 16. And I get 8.3, which makes more sense. So the average or the mean foot size of this data distribution is 8.3. So the mean falls somewhere towards the middle. I'm actually going to mark the mean on my dot plot. So my mean is like a little bit above 8, a little bit below 9. So I'm just going to mark my mean here with an X to show that my mean falls towards the center of my data. Okay, now to find the median definition is the middle number, or the number that falls in the exact center of the distribution. So I'm going to cross out from the edges to determine the median. I'm going to quickly do that up here. Okay, and my median is halfway between 8 and 8, which is going to be 8. So my middle number, my median, is 8. So the median foot size of a teacher at LPS is also 8, close to the mean. Last question, kind of the key for class today, is the mean less than, equal to, or greater than the median? If they are different, explain why. If they are the same, explain why. Okay, so I'm going to say these are definitely approximately equal to each other. Just a reminder, approximately means almost. So these are definitely almost equal to each other. I'm going to say the mean is approximately equal to the median. And here's the key thing for class today. Because the data distribution is symmetric, the mean is always going to be about equal to the median. So that's actually the definition of a symmetric distribution, is when the mean and the median fall in about the same place. And as you'll see throughout class today, that is not true when a distribution is skewed. The mean and the median are not the same. Okay, so the mean is approximately equal to the median in a symmetric distribution. The mean, I'm going to use the sign for approximately equal to, which is equals with like a wave above. Approximately equal to the median. The mean is approximately equal to the median in a symmetric distribution. The mean is about equal to, approximately equal to the median. That's always true. That's the definition of a symmetric distribution. All right, thank you for your attention.